In early September, the spacecraft BepiColombo did a fourth flyby of Mercury as part of the steering measures to enter the planet's orbit by late 2026. BepiColombo will become only the second mission to orbit the smallest planet of our solar system. One of the instruments on board BepiColombo, called Phoebus, will investigate the planet's exosphere. I recently visited the laboratory LATMOS near Paris to meet Eric Kemmerer, who is the principal investigator of this instrument. I started by asking him about the key objectives of the BepiColombo mission.
BepiColombo is a mission developed by the European Space Agency and the Japanese Space Agency to study Mercury. It was launched in October 2018, and it is composed of two orbiters, one Japanese, which will study the magnetosphere of Mercury, and one European, which will mainly study the exosphere and the surface of the planet and its interior. There are 11 instruments on the European orbiter, one of which is the Phoebus instrument, which was developed at LATMOS, and it's going to study the composition of the exosphere and its variability during the Mercury year as the distance between the Sun and Mercury changes. Phoebus is a ultraviolet spectrometer which also has two visible channels, and it is made between as a cooperation between LATMOS and two institutes, one in Japan and one in Russia, to study the exosphere. It allows to derive the composition of the exosphere with a spectroscopic analysis. And the main targets that we are looking for are helium, hydrogen, manganese, calcium, potassium, and magnesium, but also new elements which have never been studied before. The project was started around 2003. LATMOS was in charge of the UV spectrograph as the lead institute, what we call the principal investigator institute, and it was made in cooperation with Russia and Japan. LATMOS was responsible for the managing of the project, and we also developed the mechanical structure, the electronics. We developed the software and did all the integration and testing on the ground. And now we are working on the analysis of the data and preparing the operation, which will start in November 26. The light that we want to study goes through the aperture of the instrument, is collected here by the primary mirror, then is focused on the slit, which illuminates the two gratings here. The gratings divide the photons according to their wavelengths and send the light on the two detectors, which correspond to the two spectral range that we want to study. On the detectors, we can identify the different lines which correspond to different elements. The brightness of the lines gives us the density of the elements in the exosphere of Mercury. It's important because it allows us to understand the interaction between an exosphere, which is the outer part of an atmosphere for many planets, and the solar wind. It also allows us to understand the interaction between the surface and the exosphere, and from that deduce the composition of the outgassed material from the surface and the interior of the planet. LATMOS is an institute which is working on either astronomy or Earth observations. We are doing many observations and instrumentation to study the different planets, including Earth. And for instance, we are using spectrometry, which is a study of the light emitted by different elements to derive the composition of the atmosphere, for instance. We are doing some simulations of the planetary environments. We are doing some radar observations to study the ionosphere. We are doing some LiDAR emission to study the Earth's composition, wind, and temperature profiles. We are doing also some balloon measurements, and there is a set of clean rooms and some computing and development to develop new analysis of the data that we acquire from the instruments.